Thanks everyone for coming. We have Magnus up next talking about something near and dear to me, Python, and accelerating your intelligent decisions with Python. Take it away, Magnus.
Thank you. You can hear me? Very good. So thank you all for coming. I'm Magnus from DNB, a large bank in the Nordics. So I'm going to be speaking about how we have accelerated our intelligent decisioning development and then when we moved from 9.4 to VIA. So the agenda will be an introduction, the life cycle development process that we are doing today, and the key enablers, Git, containers, and then Liquibase, a database management tool. And then I'll do what was supposed to be a demo, but it's basically pictures of what we have done, and then a brief summary of benefits and impact and lessons learned. And then a Q&A at the end if you have any questions. If not, then feel free to stop me if you see me at a later stage. Yeah, so when we moved from SAS 9.4, a lot of the process that we had for generating the decisions and models were manual. That meant every step of the process is a potential failure point where you forget to do something. You forget to comment out something that shouldn't be in production or stuff like that. So you had to do a careful migration between environments, which took a lot of time. You needed to do the full end-to-end testing every time manually, which meant, well, at some points it was actually hard to know what was actually in production, which is from a regulatory standpoint not acceptable for a bank. So it was hard for us to actually say this is what's happening, this is the process that we're following, because it could change from every development. And it led to slow delivery, inconsistent environments, gaps in what version was in production, and, well, every deployment to production felt like a high-risk thing to do. We always had to schedule a lot of time. If something failed, the rollback process was tedious. So, okay, when we moved to VIA, we had to do something. So that's when we moved to a development lifecycle process that looks like this. We start with the model development, where we're working alongside of our risk department, which are data scientists, analysts that create the model that we use in our risk portfolio. So they have, well, hundreds of models depending on what kind of loan you apply for. Is it a mortgage? Is it a loan for a large tanker? Or just you need a loan to buy a car. So, and then we start the decisioning development, which is what I'll be talking about most here. But we use intelligent decisioning for that. And we utilize SAS container runtime which has containers. And then all of this combined into how can you work faster, develop faster, faster time to market, using local testing and local development on your machine. And then we aim to have an automated pipeline to deploy into every environment, meaning that at any point in time, I can actually just go into Git, what is in SIT today? What is in production today? What's running exactly at this time. I have the single source of truth every minute, every second of the day. So that's when we adapted Git, which helps us to track every change that we do on our either decisions or models. We have a full audit trail, who did what, who approved the pull requests that we have to do changes, what was changed, what configuration was done, and we also have all of the configuration or environment variables that you need for for all of your development environments, for your production environment, pre-configured so that you change it one place, you don't have to go into one-on-one decision and change or update. You have one place, one source of truth, which is very important, especially when you're in discussions with the regulators. We're following a branching strategy, which allows us to have feature branches for new stuff that we're developing that you do locally on your machine. You have development branches that automatically go into SIT, where you run unit testing, integration testing out of the box with the CI/CD pipeline. And then, of course, pull requests and reviews. 4 eyes principle everywhere. Only a couple of people with the permission to override and go outside of the pre-configured process, because every time we do a change, it should be peer-reviewed, not only by your coworkers to improve the code, but also for us to have when as a documentation towards the regulators. And also, when using Git, it is actually easier to collaborate on decisions. We have had cases where before we started to use Git as the source of truth, where one person did a change to a decision while another one was also developing something. And then both of them saved. Well, what the first person did was removed. So this way we merge properly and ensure that every change that we do is actually caught, and we know that everything is going into production in a tested manner. Then when we do merges, we have an automated pipeline that does unit testing, integration testing, as well as the stress testing for us to add to the documentation as well. So, and the key enablers for kind of going that way is, well, we use SaaS Container Runtime to run containers. But those containers you can actually run on your machine as well. You can run them anywhere you want, which is, well, the biggest pro for containers. And then you also know that what you're running on your machine is actually also what you will be running in production. It also reduces the works on my machine because, well, you're using the same image when you are testing. So if it works on my machine, it should definitely work on your machine, because you're using the same image to actually run the code. We are able to utilize versioning in a better way. And sorry, I need some water. So, meaning that Git also has the version of the current deployment, but it's also an ease for us to do a rollback on a specific tag that you have. It's fast to spin up. So previously, when we were working in 9.4, it could take days to do a change. When we moved to intelligent decisioning, it's a lot faster, but you need to know exactly where you go to do your change. when we have moved this into local development on your machine, we actually see that I can do changes in a few seconds and then test them a minute later. But even if you have a local setup and do your intelligent decisioning, very good. Consistency with your database is equally important. If you don't have a proper process to update the database with the tables or alter tables, adding columns, whatever you need, stuff will break. So that's why we are using Liquibase, where we do schema changes as code, and it's also tracked in Git, so that we know at any point of time what is actually in our database, and you can also quite easily do a rollback if stuff fails. So how it works? Well, we spin up locally, clone the Git repository. We have, I personally use what's called Podman, and then I have a Podman Compose, which basically spins up everything I need. Spins up the model, it spins up the decision, and it also does, well, from the image that you will see, it doesn't do that, but I also have it deploy all of my database changes. We expose it as an API on your machine using localhost, meaning that you can test it once the container is up and running. A few seconds, bang, you can test it, verify. Does this input work? Yeah, good. You can also then do stress testing, unit testing locally on your machine so that you know that that will work once you actually create a pull request towards other to review. Utilize Liquibase to do database updates, and then eventually a CI/CD pipeline trigger to automate the deployment. This is kind of some suggestions of tools I would prefer to use. Not necessarily a full list of everything, but basically what I use: Podman, database. Since we are using Oracle on our SAS Viya instance, I have a local open version of Oracle. I use the terminal to do the Podman commands. I use Homebrew to ensure that I have Python installed with the correct version, and then kubectl to ensure that I can connect to the local Kubernetes cluster that I have set up on my machine using Podman. And then I can use tools like Insomnia or Postman to validate the API locally on my machine. We utilize Azure DevOps today. We are actually in the process of migrating towards GitHub. That will be done within a couple of months. Well, for publishing, this is just an example of what we do when we have a model ready. We publish it to Git. That's the source of truth always, ensuring that we can then utilize the local development environment. It is a bit of a hassle to get set up, especially since we are on what's called the hosted managed service. You will need help from SAS to get it set up properly, and also you would want to do some role modeling as well, so that everyone doesn't necessarily have access to do this, because if done wrong, you can actually overwrite and break the model implementation as well. If you click, let's see here, if you use this one, replace, because then it overwrites everything. So be careful if you use that. Liquibase, as I told you, all database changes as code. This is just an example that I've created for this presentation, where basically I create a table that logs all of the decisions or all of the requests that are coming in and the response. And I'm able to deploy that using these 4 commands up top here. But I can even, if I see, for example, in my test environments, I can even do a rollback, because I have implemented scripts for doing a rollback that you can see down here. What do I do if something fails? Okay, I roll back. Takes me a second. That's fine. I don't need to spend 4 hours getting stuff up and working again. Everything is automated. And then, yeah, I like to use the terminal, at least locally. We have all of this set up in a CI/CD pipeline, so when I deploy stuff, it goes automatically. And rolling back is also easy, because I just revert to a tag that I have on my Git repository, which you also then I could then use the same tag in my Git repository and do a rollback like I do in this command here. And well, I ran the first part of the Liquibase process. Just creates 2 tables for us to see what is actually deployed to the database. Then I run the Liquibase update, and all of a sudden I have more databases, but I also have content in the database in the tables. Where here you can see all of the change sets that I have deployed to my database using the Liquibase update. And even if I then do a rollback, I see it here. Now I've done a rollback. So keeping it, sorry, this is where I did a rollback. So then it's easy to keep your database consistent with what model version of the decision or the model you are actually running. Yeah. And then I have a possibility to run the model and the decision locally. This is just a snapshot of what I've called the model service, which is a model that is developed in SAS, on SAS Viya. Though it's very, very simple. It's, I'll show you afterwards. But this is probably the key to do it. I had to redact some environment variables, or else you would be able to do some, well, that are DNB specific here. But I use the SAS base images when I build. So basically it's the same thing as SAS does when you build a container on Viya. And then I have Podman Compose that builds these services for me, builds the model service, builds the decision, sets the environment variables that I need in my decision. And then I also have a depends on, which says that, well, I cannot run my decision without actually having the model available. And you can see here, it's up and running. This takes building them. First time, yeah, it can take a few minutes because you need to download the source images from SAS so that you have them available. But once you have it available, you can do incremental testing of your either your model changes or your decision in seconds. So it's quite nice, especially for developers when they are developing decisions or models. Then I use Insomnia myself to do the testing, as you can see here. I send in a date of birth, and then are you attending Innovate, and that decides whether you will default on your mortgage or not. So if you are above 18 years old and attending Innovate, you will never default on your mortgage. I'm not sure I would get that model approved, but at least that's what it says here. And then I have the database updated, and I can validate there. But even if I do one test at a time, what's the value? Yes, you can see that it's working for what's 90%, 95% of the cases, because that's easy. Well, we also do stress testing and testing using large volumes of data to ensure that we're actually testing the edge cases as well. So that's when we're using what's called K6 from Grafana. First, I'm not sure if you can see it, but on this one, we actually ran a stress test to look at what's the response time if I stress the decision and the model. So I ran 250,000 API requests in 2 minutes, 2 minutes 30, I don't remember, which is like 100 times more than what we usually see peak, if not 1,000 sometimes. And then I can see that, well, the response times is 13 point something milliseconds, which is, well, below 100, which is the requirement, okay? Then it should be good. But we also use this to actually then validate that we're not getting any errors on the edge cases as well. So doing this on your local machine with proper test data will enable you to know that, well, once I raise this pull request, I know that this is functioning, it's working. I can already provide a test report to our business users that need to approve for them to actually also then validate that, well, this looks very good. I approve. Go to production. So then we use the CI/CD setup. I haven't built the full CI/CD setup here. I would also need some help from you guys if you to get that properly set up or 100% set up. We have had some workarounds right now, but if you request for CI/CD possibilities in intelligent decisioning, I will be very, very happy as well, because to me that's very important to know what's going in, how can I easily do a rollback of the production environment in case of issues. Yeah, so here, automated testing, automated building of the container and deploy it to the container registry. So go full CI/CD lifecycle. We've reduced our time from 9.4. We hit a record when I came in as an engineering manager. 14 months of before we went from we started development to production. Last week we did another record, 4 weeks. So it's increasing our speed drastically. It's not necessarily perfect all the time, but it's a lot better than what we had on 9.4. We are more consistent because every change that we're doing is through code. I don't want any manual process because it will eventually lead to a failure where someone needs to work overtime during a weekend. Spend it with your family instead. And then increase or reduced risk and improved quality. We see that what we deliver has a lot less errors, and well, the risk of doing a rollback is minimal. So, yeah. the lessons learned and best practices from our experience is, well, start with a contract first. Define your API before you start the development and define what is the business outcome that you want from your decision or your model. Do database migrations as code or updates as code. It will help you, even though it is a bit tedious in the beginning. Well, I would suggest using AI to do it now, because it will give you all of the liquid-based scripts within seconds. And then use short-lived feature branches in Git to do your development. Small incremental change. Less risk, faster time. Yeah. I think that's it.